yet, but you have some public here. That's good. Okay, so are you ready to start?
1 minute.
1 minute. Oh, come on. After this show, 1 minute? Really? So just so you know, guys, I guess if you're here is because you like robots. Who likes robots here? Who's into robotics? One. I see one there. Okay. Some people here. Okay. We're having this stage. Besides having the modding stuff and astronomy, we also have robots. So we're going to have robots all day long. Tonight at 9, we're going to start with a bot meeting. So if you like robots, if you ever made a robot or you want to make a robot and you want to meet someone that made a robot, we're going to have all the people here. All the robots that you see around, they're going to be here just talking. Nothing prepared, not like talking here on the stage, nothing serious. It's just showing robots and showing what they do and how they do it. So if you want to meet people into robotics, that's the time, 9 today. That was about a minute.
Yeah, okay.
Okay, so this Benoit, he's coming from France, right? He's coming from a company called Aldebaran. They make these robots, and now robots. And, well, you've seen a little bit of what the robot does. Pretty cool. But you can do way more, and that's why Benoit is here. So, first of all, thank you for coming, buddy. And thank you guys for coming. All yours.
Okay. So, for starters, I will let Nao introduce himself a little bit. So now he should stand up and talk.
Hello, my name is Now. I'm a humanoid robot, imagined and manufactured by Aldebaran Robotics. I come with a software and I'm fully programmable. I'm autonomous, and I can connect to the internet. Through Wi-Fi, I can recognize your face, answer your questions, play music, grab objects, and even play soccer like a pro. I have more than 2,000 brothers and sisters in use, all around the world, in universities and research laboratories. Do you want more technical details?
No, thank you.
Well, I guess that's enough for the moment.
I guess it's 2:30.
Thank you
which
for
I guess
listening
means we
to
should
me.
Start. Hello, I'm Peter Kern. And,
So, after these
wanna talk
few
to
words
you a
of
little bit
introduction, I will
today
be in
about,
charge of the rest of the presentation.
Visual interfaces from music.
Stiffness removed.
So I'm coming from the French company.
I want to talk a little bit about visual interfaces for music. So the workshop that I
produced this
planned
robot,
goes
and I'm going
nicely
to
with
tell
what
you a
happens
little
after
about
this.
where the robot comes
In
from
that
and
we
what you
have,
can do with it.
I think two
So
speakers
first, a
talking
few
about
words about the company in
making
itself.
physical musical
We
instruments,
used to be a
media
startup company, but now
So I'm
we
gonna
are
talk a little bit about
6 years old,
making
and
software
there's
musical
a little
instruments.
less than
And
200
we're at a
people
bit
working
of a
for Aldebaran now.
disadvantage,
So mainly technical
in that
people,
we
like engineer
are
and PhD.
looking at
Does
dim
everybody hear
screens
me?
and
Is it okay?
sunlight. And we're a little limited in space and time.
So
So
lots of
normally
technical
we
people,
have, like,
engineers,
4
PhD,
hours or
but
something
also
instead of 2.
salesperson,
And we'd be able
marketing,
to see the
communication.
screen. So we'll have to. I'm
We
gonna
have
just try to make up
3
for those
offices.
shortcomings with
The company was
raw
founded in France,
enthusiasm
in
of some
Paris,
sort and try to
where
get
the headquarters
ideas
is
across
and where
somehow.
the
I
robots
was told, by the
are
way, by
designed
someone
and
from
manufactured.
Sao Paulo that
But now we
are
have
way too
smaller
quiet
commercial
here,
offices in
that
Boston and in
our
Shanghai in China.
gentle
So
European
up to this
style
day, we
somehow,
sold more than
is
2,000
not
robots
matching the
all around the
South
world,
American
mainly to
vibrancy of
laboratories
the
and
campus party that
universities.
they have there.
So
even if
the
this
company
workshop
really
ends up,
took off when
failing somehow, I hope
this
that it's
robot here was chosen to be
energetic.
the
You can
standard
direct
platform of the
energy back at
RoboCup.
me, even if that
So
energy
if you
is
don't know the
anger or
RoboCupper,
something,
you have Teams
then
present
you should rise up
just over
and
the corner.
overthrow me and take over the workshop.
But this is a competition of robots playing soccer.
So I have no idea who you are. Well, I know a couple of you. I have
Now,
no idea who most of you are.
we are a commercial
so tell me, how
company.
many people are
So,
kind of developers?
that's why I
How many
wanted
people are
to
not
remind you
developers?
with this
Not
slide I got from
developers,
the communication department.
Or
So
not very good
we're
developers.
trying to sell robots to make people this happy.
All right, so we've got a kind of a mix of developers. For the
But
people
we're
who
not
are developers,
selling any kind of
how many
robots,
you
not
are
vacuum
Java
cleaning
developers?
robots, not industrial robots. We're
How many of
making
you have ever used
interactive
a
robots like this
graphical
one.
data
So that
flow
means
language? language.
humanoid
PD or
robots
Max MSP
that can
or Pure
talk to
Data
you,
or
see what you do,
BBB,
and
B4.
react to what you do.
Okay. Wait a minute. Some
And
of those
the
people are
long-term
not
goal of
developers.
the company is to
They're,
have service
RMQs
robots,
and
so
going
robots
outside.
that
Okay.
can
So we have
help
a mix of people.
in their daily life, for
That's good.
example.
That's exciting.
Robots that can
A
help
little bit about
older
me.
people, or
That's my
robots
name.
that can
I'm
help younger
not
people
European
in education
originally.
tasks.
I'm from. I grew up in
Or
Kentucky.
for example,
lived in New York
when I'm not
and have lived in
doing
Berlin
this kind of presentation,
since the fall.
I'm
So that's
work.
who I
My
am.
real job is in a
And
team
then some
where
people know
we
me through
develop
this website
application
that I run
for these robots,
called Create Digital
as opposed to
Music.
teams in R&D that
If you like the
write
presentation
tools
today,
or
and don't read
write
the site. You'll see more
software
of
libraries
this stuff on a screen
for
that
the
may
robot.
look brighter
So
and not be
my job is
glaring in
on
sunlight in
a
Temple
project
Airport.
where we
So
design and
I run
develop
two sites. One's called Create
applications
Digital
for
Music and
children
one's
with
called Create Digital
autism.
Motion. And
So
we talk every day
maybe you
about
know autism, it's a developmental disease, and
music and
children with
visual technology, or
autism
how
are
people
known to
will
be
use this
attracted
stuff
towards
to make
robots
music and
and
live visuals and
mechanical
art and
and
things.
electronical devices in
And,
general. So we are
I'm
trying
especially
to
interested in how
benefit,
design feeds
take
into
advantage of this
music
attraction toward robots
live visuals
to
and art and all
build
those things.
theoretical
These websites.
or
And if you don't like
educational
to talk today,
behaviors.
then that's another place to direct anger and resistance.
So we are not just
So,
selling
I wanna-
this
I
robot
wanna think a bit about- well,
to
actually, that's the most
laboratories and
important
universities.
question, not the question
There's
that I
also
remember to ask,
one
but
way
this one.
you,
How many
as
people are
individual
musicians
programmer,
of some
can
kind?
have
Playing
one
music.
robot like this, and this is called the developer
like
program.
Left, right brained, or on
So
the left
the-
side of the room, or something is happening there. I
The
don't know.
idea behind
Um,
this deal is not that
So, and some of the rest of you are not
we
musicians, but are
will
curious.
give you a robot if you give us some money.
Okay.
So
How many
this
people
is-
can read music?
Yeah.
Oh wow, cool. Okay. So,
Okay.
but I'll assume the rest of you can't.
Does everybody? Does
So
everybody
we
hear
have
me
this
now?
interesting thing,
No?
and this
Okay.
is why it's
Okay.
the having the hardware workshop right
So
after
I was
this
telling we
is,
have this community
sets up
of
a kind of a
developers
nice comparison. So one of the things that I do aside from writing,
where for
I'm a writer and a musician.
discount fee with
and I have
respect to the
a
price
classical
that
training,
we
so I do know
sell
how
the
to
robots
read
to
music
academia.
theoretically,
You can get one
somehow.
robot just like this, and all the
the other
needed
thing that I do is
tools,
uh,
software tools that I'm going
in
to
addition
show
to working
later,
on this open source software project,
plus the
I work on this
cross
open source hardware
compilation stuff,
called the
a
Meebler.
simulator of the robots
And when you do
to make
hardware
the
design,
development of
something that you'll see
applications
less
easier.
of, I think.
And
at
we
campus
also
parties.
provide
But when you're in the
non-technical
hardware
tools
world,
like
you really have to
a
make
dedicated
tough decisions.
forum, dedicated
Because,
website for hosting
you know,
your source
every knob
code.
that you put on the hardware
We
costs
provide
money and
2
takes up
years
space
warranty
and has a circuit
in
sitting
this
behind it.
developer
And you want
program
them spaced
and,
out.
and
So actually
access
somebody
to
complained to us
the
because
Now
his
store, so
fingers
which
are
is
fatter
our
than mine. You
application
want enough
store when
space
we
between
can
knobs.
distribute
so all of these decisions
or
are
sell
constrained
the
by the
behaviors,
physical
the
world.
application that you write.
Not only by
And
cost, but
as
all
part
kinds
of
of
this
all kinds of elements
program,
of
we have
practicality.
regularly
so when you
meetings
design
where
something
all the community
to
gathers.
work for
For
music
example,
and
there
you
was
use
one in Paris
a physical
in spring,
medium,
and there
you-
will be one in a
your,
few weeks
your choices have
in
all
London.
these boundaries and constraints. When we work with software,
So now,
when we
what
work with
can
software,
this robot do?
we have something
So
a lot
he's
closer
a
to
humanoid
this.
robot
We have just a complete.
with 25 degrees of freedom, so we can make lots of nice movements, as I showed earlier. And that's a computer, so he has all the things that computers have, like a CPU on the head, which is a Atom, Intel Atom. He has a Wi-Fi card. I'm not using right now because the Wi-Fi environment is a bit overcrowded. So I'm using the Ethernet plug on the back of the head. There is also a USB plug on the back of the head. So, but that's not only a computer, that's an interactive robot. So you have lots of sensors, starting with the tactile sensor here on the head. You have 3 buttons. You have cameras. So you have a camera in the forehead, not in the eye, in the forehead, that is looking straight in front of us. And there is one camera in the mouth, looking down at the feet. In the eye, you actually have infrared captors, so you can zap the robot with a TV remote control. The hands also have tactile sensors, and here on the feet you have bumpers, so you can know when you bump into an object. And what did I forget? Yeah, I forgot the inertial sensor that is in the torso, as are sonars to detect the, for example, walls or obstacles in the environment. And you have microphones all around the head, so you can know which way the sound is coming from. Okay, and now before going to the more technical part, where I will show you how to actually program this robot, I made this layer architecture diagram just to show you what's running on this robot. So on the bottom we have the hardware layer with all the motors and sensors and CPU, etc. In order to let that run, we have the operating system, which is a Linux kernel. And then all the low-level functionalities are provided by a middleware that was developed at Aldebaran that we call Naoki, and which provides several APIs and libraries. For example, we have the AL Motion library, which provides API for all the motor primitives, like put your hands here or go to this X and Y position in the space. We have, for example, this AL object recognition, which is vision learning library, where you can teach now to recognize an object, for example, a red ball, and then when the robot sees a red ball, it will raise some event. We also have, for example, what we call the behavior manager. It's what I will be using to start applications. It's used to, well, start, stop applications, install applications. And there are also some libraries that we did not develop ourselves, but that we took from the open source world, like Kernman, which is the connection manager that handles Wi-Fi connections and direct connections. And we have bindings to various languages, so you can write your program in your favorite programming language. I will be using Python, and you can run that on the robot. So now I will, in the rest of the presentation, I will concentrate on the rest of, on the most upper layer that I call application. It's any interactive program that you can run on the robot. So I showed dances before the start of this session, but you can have other applications where, for example, the robots get some content on the internet and read it loud, like the RSS reader, or Follow Me, which is a nice application where you can actually walk the robot taking his hand and he will follow you. I can show that later. Okay, so now let's start to make an application. So for this, I will be using a tool that we developed here in Aldebaran. Yep. Okay. So I will be using this choreograph tool. So it's choreograph in French, which is the French name for choreographer, which is the guy that designs the movements that dancers will execute in a ballet or something like that. And I think it's a nice name because it really says what the software does. So here I'm connecting the software to the robot, and now in this robot view, you have a virtual robot that is the image of the physical robot here. So if I move the robot, you see it here, and in the other way around, if I put stiffness in the robot, and then I want to turn his head, the robot turns his head. So these functionalities are just to have a basic control on the robot. on the robot itself and on all the, for example, sensors of the robot. We have, for example, a video monitor here that, so this is the camera. This is the stream of the camera in the robot's forehead. So now, if I turn the robot head, you will be the camera moving. Okay. Now, suppose you want to make some nice movements, like the dances that I showed earlier. So this is a bit complicated, but we have tools to do that. So, choreograph is not just a way to control the robot, it's also a graphical programmation tool. So you can actually make a program to run on your robot without having to write code, because you just have to take boxes. So this is the main concept of this programming tool. These boxes you can execute, and behind these boxes in Choreograph engine, this will produce some code that will have the desired behavior on the robot. So you have different kinds of boxes. What I want to show you now is how to make the robot move. So this is what we call a timeline. So I hope you can see, you can read this. It's a little small. So you see that on this box you have squares here on the left-hand side and on the right-hand side. So these are the inputs of the box, and these are the outputs of the box. And this is the start of the behavior. What will happen first when I will play by clicking this button, the behavior on the robot. So now I'm linking my box to the beginning of the behavior. So when I will play the behavior, the thing inside the box will be executed. For example, I have a say box here that will make the robot say hello.
Hello.
Okay. Well, this is not a totally interactive application, but it's a nice start. So I said I wanted to show you how to let the robot move. Inside this kind of box, we have what we call here a timeline. So we have the time here, and at a given instant of time, you can set articular positions. For example, I want you to raise your arm up and to turn your head. Okay. And here at 30 seconds, I will want you. I have a clicking problem. I will want you to go in that other position with the head on the other side. So this is the very basic way to edit the motions of the robot. We have more complicated tools like this one, where here you can see the different commands that are given to the different motors. And you can edit that, saying that okay, you can define very precisely the different commands that will be sent to the robot. And you can edit the way the robot will go from one position to another. So the interpolation of what will happen between these two defined positions. So I will not spend much more time on these tools to make the robot move, because we provide tools to solve the technical aspect of the problem, but making a really nice dance that, like we showed earlier, it's not a technical problem. It's more like an artistic problem, if that makes sense. That's character animation, as in Walt Disney or Pixar or things like that. And that's complicated. And most engineers don't have the skill or the will to do that. So actually in Aldebaran, we hired professional animators that that produced an animation library. So we have all kinds of emotion or standard gesture like hi, these kind of things. We have a quite big library with different flavors of exhausted or angry or things like that. So I will make a small demo. So first, I will let the robot stand up. And then I will make the, let's say, angry number 3 face. Okay. Yeah, I want to connect to the robot. Okay, and let's go. So this was when I was a little pissed off, but not too much. So this was to show you that you can render feelings with this plastic box that don't have proper eyes or don't have a proper mouth. But with skills, animation skills, or with our animation library, you can do that. So now for the rest of the session, I will try... Oh. Sorry, that was a crash. For the rest of the session, I will write an application, a small application, where the robot will stand up, will say something, and then we'll ask you, oh, what do you want me to do? And what I want him to do is to show the red ball tracker. So it's a nice feature that we developed where the now is able to follow a ball that I will show him. Okay. So we will start with this stand-up box. Okay, no. We will first say something. So I will show you the say box. So the robot will say something. Now, if I go inside the box by clicking here, I see inside the say box we have this localized text box where you can input text in lots of languages. And then this localized text box will go into this say box. So you can remark that this link here is black, whereas this link here is blue. I don't know if you say that, if you see that. Okay, so our links are typed. So black is just an impulsion, it's just a trigger for the next box, when blue is for a string. So it's no surprise that the output of localized text is a string and the input of the say box is a string. So the robot will say, hello, I'm Campusero, which is the name I defined for this robot. Let me stand up. So now if I execute this behavior, oh no, sorry, I'm not connected to the robot, that's why. So I'm connecting to the robot here. Sorry about that. We have lots of troubles with all the Wi-Fi in the tables over there. Okay. I'm in. So now, no, I'm not in. Okay.
Hello, I'm Campusero. Let me stand up.
So this robot just told the text that was inputted in the box. So now, after saying this, the robot will actually stand up, and if he's already stand up, he will not move. So that's nice, but imagine we want to put that behavior on another robot whose name is not Campusero. We will have to edit the behavior. So I will make something nice here. I will get the name of the robot from another box. So maybe you don't see, I'm modifying the box with a %s, so that's Python syntax, and I will explain later. But for now, I will go in the library. We have this getName box that actually gets the DNS name of the robot that's Campusero, and we will use something that we call a parameter. It's like environment variable of the box. So I will edit the say box here to add one parameter. Which I will call host name, and this parameter will be a string. Okay, and then I can link the output of the getName box to the parameter, which is the range, and this will automatically take the parameter from the box and put it in the say text box. And now I have to do one more thing, that's editing the Python script behind this box in order to get the parameter. So that's a little okay, I don't know if you're able to see much. Okay, this is only Python syntax. I'm just copying and pasting. I'm just copying and pasting some code to make sure that this say text box can get the parameter from the other box. And saving, and now it should
Hello,
work.
I'm Campusero. Let me stand up.
Okay, so this works. Now we will do more exciting stuff. So first we will add a sit down box at the end of our behavior. So I will just sit the robot so it's easier for him to stand up. Okay. Now we'll make the stand-up operation a little bit more robust. You see that in the stand-up box you have two outputs. One is success, when the robot actually stood up, and one is failure, when for some reason the robot could not stand up. So if the robot cannot stand up, we will make him say something like, ouch, maybe I should stay on the floor. So this is the failure, and in this case, the robot will stay on the floor like that. And if the robot actually managed to stand up, we will go to the rest of the application. So the rest of the application is this choice box that I will explain later. So I'm just linking the stand-up, or in case of failure, the sit-down box, to the rest. And now you see it's beginning to be a bit crowded here. So I will separate all functional blocks to make it easier to understand. So we have another tool that we call a flow diagram here. So I will put all these boxes here of the stand-up sequence in this other box, like that. So I'm cutting and pasting up. And so now when we are in the top level of our program, we just only see a box that is called init sequence. Okay. Now, after the init sequence, we will make some interaction, some verbal interaction with the robot. So that's what we're doing here in this choice box. So in the choice box, you have one question that the robot will ask, like, what do you want me to do? And then we have these words here are the choices that will be expected by the voice recognition engine on the robot. So the answer can be nothing, I don't want you to do nothing, or follow the red ball. So because I want to show you this red ball tracker, or maybe only ball if the voice recognition only understands ball, because it's really noisy here. So I don't know if that will work. So. And then, in order to process what is the output of this choice box, I will have a switch case. So if we understand nothing, we will directly go to end the sequence, where the robot will sit down. So if the robot understands nothing, we will, oh, no, up. So I'm making one other flow diagram to contain other boxes. And the sequence. Okay. So, in this end sequence, we will have a simple sit-down box. And we will let the robot say something. We will let the robot say something like, oh, it was nice to play with you. So let me get this right. So it was nice to play with you. So let's test this.
Hello, I'm Campusero. Let me stand up.
Okay, and Now he will stand up.
What do you want me to do?
Nothing.
Nothing. It was nice to play with you.
Okay, so it was a bit long to come, but we have an interactive application. And now we'll go to the interesting stuff, actually, the red ball tracker. So if we understand ball, or if we understand follow the ball, we will go to another block. We will go to this tracker. Okay. We will go to this red ball tracker. Up and up. So, let's go.
Hello, I'm Campusero. Let me stand up. What do you want me to do?
Follow the ball.
Ball.
Okay, I'm sorry about that. It seems that with the light here, it's not working. It was working over there. So I will try to make that again.
Hello, I'm Campusero. Let me stand up. What do you want me to do?
Follow the ball.
Ball.
So maybe we can try to see what the robot actually sees. No. Okay, sorry, I think I cannot make that work now. So instead, before going for some questions, I can demo other behaviors, interactive behaviors that we have. But I hope that the little programmation that I did here showed you that you can actually have behaviors, create behaviors, without having to know too much about Python and programmation. So I will show you this follow me application that I told you about.
I want to come with you.
Okay, this is one of the nice things that we can demo. I think I have time for one more application before we go to questions. So I will show you an application that we call Guess Sports. So it's a little game where the robots will mimic some sports, and you have to guess what sport it is. Well. Okay, it seems we have some problem here. Okay. I will try to go with an...
Show me a Red Bull to make me walk.
Okay. Let's try this way. Okay, so now like this it's working. So, the Red Bull tracker. In this Red Bull tracker, now we'll try to maintain a constant distance to the ball. So we will move to the ball or move back if I get the ball too close. Okay, I see somebody with a red shirt. Maybe sometime. No. It's okay, but it happened that in the audience there is somebody with a red shirt, and now I think it's a ball, but it's okay. Okay, so maybe I can begin to take questions, and if I can show you other applications, I will do that afterwards.
Can I have a question about the sensors of each motor? I'm interested if each motor has its own sensors, so the computer recognizes where the position of his arm is or the position of his head.
Yes, so I'm sitting the robot.
Stiffness removed.
All the motors have their own sensors, so you can know what the position of the articulation is at any point. In the timeline that I showed you, where there were the curve giving the position of the robot, interpolating between two positions, you can actually monitor the position of each of the motor. Yeah.
Hello? Oh, hey. Are there any plans to have this robot think for itself at one point, say make decisions or real-time movement if say an obstacle comes in its way if it's walking?
So, this is a question about artificial intelligence at some point. So, well, artificial intelligence, it's a software problem, and as a company, we sell the hardware and some smaller software. So, if you want to try to make now intelligence, you can try, but it's a complicated problem. The state of the art in robotics, it's like the RoboCup, letting robots play football, and with all due respect to football players, it's not the highest function that we can call artificial intelligence. So right now is used as a research platform in artificial intelligence, but the state of the art with such a small machine, this is not designed to be a really record breaker machine. It's designed so that people can actually buy one someday, not today because it's expensive, but at some point. So it has limited power, CPU power, and limited sensors. So it will be complicated for now to be really, really intelligent.
Hello. Yeah. Thank you for your talk. I have noticed that the robot can dance. No?
Yeah.
And I'm curious whether the robot can really respond to the music or it can nur dance with some specific music.
Okay, so the dances that I showed you earlier, it's only choreographed movement. It's a set of movements that is only repeated. And for example, if the robot falls, it will sense it falls and it will stop, or it will go up and continue the dance. But for example, when Nao does this acrobatic movements, there is no dynamic balance control. So that's one point. But then, if you want to create your own application where the robot dances and reacts to music, and in the same time keeps dynamic control of the balance, you can do that. Actually, it was done by somebody at Aldebaran. We have an application that is the autonomous dancer, where the robot will have some small dance movement like that, corresponding to the rhythm of the music in the environment. So this is something that we can do and that we did.
So the robot runs Python, but is there a Python interpreter running inside the robot in the Intel Atom, or is the Python pre-processed at the computer?
I think there's a Python interpreter running on the robot. There's a... Yes. There's a Linux. The operating system is a Linux, and in the newer version that is running on this robot, you can actually run the virtual machine of what is running on the robot on your computer, and you can do whatever you want.
Is it available? Is there a public API to program the robot in C++ or C or something more directly?
Yes, so in the tools that come with this choreograph software, you have more technical tools like the cross-compilation chain and things like that. So you can compile your library in C++ and download it on the robot or flash it, and then execute your program.
Okay, thank you.
And yeah, what I did not show you, so some of the boxes that I showed you were only plain Python scripts, but there is a way to link your C++ library inside a choreograph box. So you can use any library you found on the internet or any library you created yourself. So maybe I can show you some other. Oh. So I'm just taking 2 minutes. If you will stand up. Or maybe not. Okay, I'm sorry. I cannot get that to work, so.
Maybe last question.
Okay.
Hi, I just want to ask if it's possible to use the program, the choreographer, for another kind of robot, except this one. Like if you mod the application for use for your robot which you built.
So in the company, we have this small robot, and there is a research project with lots of French robotics laboratory, where we build a bigger robot, 1.30 m humanoid, that's called Romeo, and that uses the same tools, the same now key middleware that I was telling you about, and the same choreograph tool. So we already have 2 robots running on that software. And it's only a matter of the 3D model of what your robot looks like and the motor and the articulation and things like that. I think there's a big XML file describing all that. And if you want to use Choreograph for a new robot, you just have to build that model, that XML file. So it works. We did that for 2 robots.
Thank you. Oh. So this was Benoit. Thank you for the amazing dances. I love it, and you guys loved it. So I believe you're leaving today, right?
Yes, but I will be available at some table here if you want to discuss, if you want to have goodies like badges, etc. If you want to have more information about the developer program. And one thing I did not say before is that we are currently hiring a lot of people. So if you want to work with this nice robot in Paris or somewhere else in the world.
Right, I'll give you my CV just in case. So you guys didn't listen anything. He's not looking for people, no jobs. I'll just give you a couple of CVs and that's it. Okay. Done. Okay, thank you very much. He's going to be right there. So thank you, buddy. And if you want to see more Now robots, we actually have a bunch of Now robots there in the soccer field. So if you want to ask them questions, these are users, probably